it'll say type error, cannot convert int to string. So that's the idea here, is that normally you can't do that because it's a type error. Now we can close out of this, and for example, we can say exception, we print, let's say this is some other code, we could say do more things, but then the most important part is print code continues onward. So we save and run that, and we see that even though we hit this exception, and during that exception we can do some more things, the code can continue. So we got that exception, okay, that's fine, but we continue on, because otherwise, if we say, let's just delete this and this, we can highlight this, and I believe I talked about to shift a block of code over, you can highlight it and hit tab, right? Or you can hold control and then the opening bracket, square bracket, and that will shift things over for you to the left. You don't have to do this, but you can just watch what happens here. But if we run this without the try and except, we run the try, we're trying to do this, but then it fails and we're given this type error, and the code does not continue onward. So we've stopped. And that's the detrimental part of all this. It results in catastrophic failure. Now you might think you've programmed your code completely and perfectly and you don't have to worry about any of this stuff, but there are some things that might be out of your control entirely. A good example of this might be if you're using, say, URLlib and you're trying to access a link or something like that, or you're working with an API and it throws an error and you weren't prepared for that error, and everything else in your code makes total logical sense programmically. I don't even know the proper way to say that. Programmingly. Everything makes sense, and you might think that you've got perfect code and you don't need to try and except, but it's always good to have one because there are circumstances that you just can't see coming. So we're going to go ahead and put this back in a try. So try that. Except exception as E. Print the code continues onward. Now, if you recall, this was actually a type error. So what you can do, though, is see except exception as E is just kind of like a catch-all for all exceptions. Okay, so you could try except. You could do try except exception as E. But then what else could we do? Like, what if we did except type error as T? Okay, so we can call that specific type error. So we say type error as T, print type error triggered. Okay, so now we can save and run this because we knew this was a type error. So we can see running the try, type error triggered. But what if we had a different error? What if we said, instead of 5, we said 5 plus x? So we save and run that, and we see that actually here, we are still thrown this catastrophic error because we got a name error. X is not defined. But we still want to use this. So the question is, can we put two exceptions together? Well, we can say except, let's try name error as N, print name error triggered. So can we do that? We run that and we see actually yes, we can do that. We can stack all of these exceptions on top of each other, and so we can call type error. If we have a type error, blah blah blah. If we have name error, we can call for that. And then finally what you could do is say you have a few very specific errors that you want to cover, and then at the end you decide, okay, now we'll just do except any other exception as E, and then print general exception like that. So we'll save and run that, and we see that we hit a name error, so that's okay. And now if there happens to be any other error, we won't have to worry about hitting it. So let's think of an error that we can possibly trigger. So let's say in here we do import Mars. Okay, so we don't have a module named Mars. So this is going to fail. We're going to hit an import error. So we run this, and oh shoot, hold on. We got to import Mars above the X there. Okay, run that. And now in this time we got an import error, But we don't have import error covered here, so it just hit the general exception. So maybe we don't care to cover specifically the import error, so we trigger the general exception error. Now, from here, generally you might want to think about saving the specific problem. You can either use Python's logging function and log the error in like a log file. You can also just save it to like a notepad.txt file and just say, hey, we had this error. Here's what happened. You can save the whole error to it. The other thing you can do is also, like here, since we hit this general exception, we have general exception, then you could still print string E, and then say you hit name error, print string N, and like we do this, whoops, hello, X, save and run that. And so here we can see that, the name error is triggered. And then we also might want to say, hey, this string N, what name error was triggered? Well, the name error is saying name X is not defined. And then we can save this to either a log file or a notepad file, just some sort of or database of errors. And so we can see as a developer what's going wrong in our script, so we can later better handle that. Because really, you don't want to hit exceptions at all, right? That's not ideal. Now, another example of where exceptions can become pretty useful is, for example, we could say, we can delete this part of the try loop, and we could say try input, and we're going to say the input text, so this is kind of like raw input, so this will allow the user to add input. So we did already kind of cover this, so we'll just say, what is your name, again, and then we'll add the space here, and then print. And then let's say string, and we're going to say this input is going to be equal to name equals input, and we'll say print string name. But we know, for example, that should be a string, and then we might ask, what is your age, and all this kind of stuff. And we're expecting specific numbers or strings, let's say here, and then if your age, it would be an integer. And then we could do math on those, or say hello, name, or whatever. But if the user doesn't enter that, you could throw an exception, and then you could make all these, you could say type error, and you can kind of alert the actual programmer, for example, print, let's just say print X, save and run that. We see name X is not defined, and then so name error triggered. And then you can kind of intuitively say, like, say you have programs, and sometimes people deliberately try to mess up a program, or other times too, people just maybe typo, or they're not really sure what to put in a specific field, and maybe you have very stringent requirements or whatever, and you want to throw some sort of an error. This would be how you do it. You could customize the error, and you could say, hey, please remember to, I don't know, capitalize the first letter of your name, or if you're looking for a specific password, let's say, and you notice that maybe the user entered everything in all caps, you could say, hey, it looks like you did all caps, something like that. Anyway, you can customize your exceptions to be very specific to the type of exception, and then you can kind of help the user of the program remedy the problem, hopefully, before it actually crashes the program, so they can continue using it. So that's going to conclude the error handling with try and except. The next tutorial is going to be covering lists and tuples, and then we'll cover list manipulation, and then finally dictionaries. So stay tuned for all of that. Thanks for watching.